So hello and very good morning, dear students. I hope we you have started doing the questions of differentiation. Okay. So in the today's lecture, I have come up with one topic, that is chain rule. I find some students facing problem in understanding the chain rule, which is like very easy topic. I'll make it easy for you. So first of all, let us understand why the chain rule. Okay. So as I told you in previous video also, or like previously, that chain rule is used to simplify the function or to differentiate a function in a very easy or comfortable way. That is why the chain rule has been introduced. Okay. So as this rule can be used in each and every question, but we don't need actually, because if we can easily differentiate a particular question, then we don't need any rule. Okay, but this chain rule facilitate us to solve a problem, a complex problem, in easy way. How is it? So let's take one question only and let's understand how. Okay, so I'm taking one question. Okay, I'm taking like cos root x. This is the very easiest question I'm taking, and I'm explaining the chain rule here. So as you have a trigonometric function, and this angle of the trigonometric function is in root. Okay, so how the chain rule you can apply here? You consider this complex part as some t, say for example. Okay, so let's consider this complex part to be t. So and you consider, if you consider this y is equal to cos root x, and root x you are considering t, then what will be your y? It will be cos t, because you consider this as t, so y will be equal to cos t. Now what you do, you differentiate both of them. You differentiate this with respect to x. So what you will get? So dt dx, the differentiation of t with respect to x. So what it will be? 1 upon 2 root x, because root x differentiation is 1 upon 2 root x. How? X to the power half, use x to the power n identity. Okay, half x to the power half minus 1. So half x to the power minus half, take this in the down, so 2 root x. So that is how the differentiation of root x is 1 upon 2 root x. So we got dt dx as 1 upon 2 root x. Keep it aside. Come here. Y is equal to cos t. So differentiate this y with respect to t only you will differentiate, because we don't have x here. So differentiating y with respect to t. So it will be dy dt is equal to cos t is minus of sin t. Clear up to here? Okay. But our question was in terms of y and x, and we need dy dx. So dy dx can be attained on multiplying dy dt with dt dx. Actually we think in such a way, actually we don't think, it's not the correct way, but to make you people understand, see this dt and dt, they can be cancelled, which we don't have to cancel, because this is not a division operator, as I already told you. Okay, so we think that dv dt will self adjust with dt dx to get dy dx. So dy dx is nothing but dy dt into dt, and we have both the answers. This is minus of sin t into, this is what, 1 upon 2 root x as y and x. So we need to replace this t again with root t. So minus sin root x upon 2 root x. This is the final answer. So that is how chain rule helped us to understand this in a simpler manner. Now this is very easy. When you will go in the complexity of the questions, there you will be requiring the chain rule. Okay, let's see some more questions here. Okay, so we have the next question as root of tan root x. I'm taking this question from your book. Okay, so let's do this question now. How we will do? Now what you will consider in this question? Okay, so it totally depends on you, that whatever you consider, accordingly you have to do the solution. So if at all you can see, this is y equal to, so if you consider only this root x is equal to t, then your y will be under root of tan t. This is the one you can consider. Or else if you consider this whole as t, so t is equal to tan root x, and here you will get y is equal to root t. This also you can consider. Okay, so you have to work according to it. Okay, so anything you can consider. Let's take this and solve. So let's take this thing, this function, differentiate this with respect to t. So dy dt, this is root function. So root of, as root of differentiation of root of x is 1 upon 2 root x, so it will be 1 upon 2 root tan t, and going inside, that is function of function. Okay, so inside you have tan t, so tan t will give you sec square t. So finally sec square t upon 2 root tan t. Now coming here, you have dt dx will be 1 upon 2 root x, simple. Okay, now multiply these two to get dy dx. So your dy dx will be equal to, and replace this t with root of x, so sec square root x upon 2 under root of tan root of x, and this is 2 2s are 4, and root of x if you multiply inside, so x. Are you getting this? I have multiplied these two. 2 2s are 4 here, and this is in root, this is also in root. So root of x tan, and then this t root x. Okay, so that is how we have done. Alright, moving on to the next question. You have such type of question where you are given with fx as a series where x to the power 100 upon 100 plus x to the power 99 upon 99 and so on up to x plus 1. This is nothing but x to the power 1 upon 1, and this is actually x to the power 0. No, it's only 1 only. Okay, so you have to show that f dash 1 is equal to 100 times of f dash 0. Now what is this f dash? This is nothing but the differentiation. Okay, if you differentiate fx, it will be f dash. So differentiating, so this, let's differentiate this series. So it will be f dash x equal to x to the power 100. What will be the differentiation of x to the power n? N x to the power n minus 1. So 100 x to the power 100 minus 9, you will get 99 upon 100. Similarly, you will get 99 x to the power 98 upon 99, and so on up to this x. The differentiation of this x will be 1, and this 1 will give you 0. Can you tell me what will be the differentiation of the term which is just before 1? So it is x. Okay, and this one differentiation is 0, which is we can remove. Okay, so you are left with this. Can we cancel this 100 with this 100, 99 and with this 99? So finally we got x to the power 99 plus x to the power 98 and so on up to x plus 1. We got this as f of x. Now we need to show f dash 1 is equal to 100 times of f dash 0. So f dash 1 will be what? In place of x, you have to put 1. So 1 to the power 99 is 1 only. 1 to the power 98 is 1 only. So up to here you have 99 terms. Okay, so the sum will be what? 99, and plus this one you will get as 100 as the answer. I hope this is clear to you, because x to the power 99 to x to the power 1 you have 99, and we know 1 to the power 99, 1 to the power 98, 1 to the power anything is 1. So this total 98 plus 100, so 100. F0, what do you mean by F0? Because in the proof we require F0. So F0, so up from x to the power 99 to x to the power 1, the whole answer will be 0 plus this 1, so you got 1 as the answer. And if you multiply 100 here, so you need to multiply 100 also. So as 100 is equal to 100, So hence shown. Okay. Okay, now let's come to this question where you are given with root of x square plus 1 plus root of x square minus 1 upon root of x square plus 1 minus root of x square minus 1. So what logic you will apply here to differentiate it? Okay, so y is equal to. So the very first thing which will be in your mind, that let's directly differentiate it, and you will use division rule over here, okay, which will take you to very complex steps, and at the end you will be very much confused and maybe you won't get the answer. So it is better to just simplify our question so that we can easily differentiate it. So now from now in this chapter and also in integration also, we will be trying to simplify our question in a very easier way. So here what can you see, that can we rationalize the denominator so that the things will be somewhat simplify in the simplify. So let's rationalize. So after rationalization, your second step will look like this, isn't it? Okay, I told you that always in the denominator you will have identity of a square minus b square, and in the numerator you will always have the identity of a plus b the whole square. Okay, so a plus b the whole square means like this. Okay, so a square plus b square plus of 2ab. So y is equal to a square. What will be the square of this root x square? Square with the root will be cancelled, so we'll be left with x square plus 1. Here x square minus 1 plus 2ab. Okay, and here in the down square to root cancelled. So x square plus 1 minus x square plus 1. Okay. Here 1 to 1 cancelled, here x square to x square. X square plus x square, you will get 2x square plus 2 times of under root this into this. In the common root I am writing because they both are in the root, upon 1 plus 1 2. This 2 you take common, this 2 you can take common, it will be cancelled with the 2, and finally you will get x square plus under root of a plus b, a minus b, so a square minus b square. Now can you differentiate this? Yes, it is very easy to differentiate. How? dy dx is equal to, what will be the differentiation of x square? 2x plus, this is root function, so 1 upon 2 root x to the power 4 minus 1, and going inside function of function, it will be x to the power 4 will give you 4x cube minus 0, because one differentiation, so we can remove the 0. Okay, this 2 with this 4 will be cancelled, and finally you will get the answer. Okay, let's do some more questions now. Okay, let's understand this question where we are given with y is equal to root x plus 1 upon root x, then we have to show 2x dy dx plus y is equal to 2 root x. Okay, so I'll explain you how you can prove this, but let's take the given part, let's differentiate, and accordingly we will see. So y is equal to, before differentiating I just want to tell you that please simplify this. How you will simplify? See, this is x to the power half, and if you take this up, so it will be x to the power minus half. Okay, now you differentiate. So dy dx is equal to, what is the differentiation of x to the power half? Or root x is 1 upon 2 root x. Okay, plus here n x to the power n minus 1. I hope this is clear to you. Now 1 upon 2 root x, it will be 1 minus 1 upon 2, and if you take this, this is x to the power minus of 3 by 2, because minus half minus 1 minus of 3 by 2, and if you take it down, so it will be of positive x to the power 3 by 2. You know what is x to the power 3 by 2 actually? See, let me explain you. X to the power. this is x to the power 1 into x to the power half actually. Because x to the power 3, it can be bifurcated in x to the power 1 into x to the power half. Or this is x root x. Always remember x to the power 3 by 2 is x root x. So shall I write this root x root x, okay? And here you have dy dx, okay? Now what we can do in the proof, you take LHS. We have dy dx with us, this. Or you can just do one more thing, take 1 upon root x common. So you will get 1 upon 2 root x because they are having, so 1 minus 1 upon x, okay? Or else take the common, so x minus 1, so x minus 1 upon 2 x root x. So you are having dy dx as x minus 1 upon 2 x root of x. Now see, this is dy dx. You take this 2x here because it is in the denominator, so it will go here up. So it will be, because see, it will be somewhat with our proof, okay? So take this 2x here, so it will be 2x dy dx is equal to, now we are left with x minus 2 upon root of x. Is it clear to you? Okay, I have taken this 2x here just to mold it into our proof. So 2x dy dx is equal to x minus 1 upon root x. Now 2x dy dx, you just separate this root x with this x and 1. So it will be x upon root x minus 1 upon root x. I hope this is again clear to you. Or else x upon root x, this x can be written as root x into root x, cancel one root x, so you will get root of x in the up minus 1 upon root of x. Okay, is it clear again? Now you have 2x dy dx as root x minus 1 upon root x. Here you have y is equal to root x plus 1 upon root x. So what you do, that from here you take under root of x here. So y minus root x is 1 upon root x. So you have this as the equation, okay? Or else you could have done one more thing, but no problem. Why I did this? Because 1 upon root x can be replaced with y minus root x. So put the value here minus. So 1 upon root x can be replaced with y because I need the y proof. Okay, that is why we are doing so. Bracket y minus of root x. So this is replaced with this value. Now you are having 2x dy dx root x minus y minus minus, you will get plus of root x. Root x plus root x, 2 root x, and you take minus y here, so it will be 2x dy dx. If you take minus y here plus y, root x plus root x, 2 root x. So hence proved. Okay, understood? Okay, please understand this question very seriously, that you are given with y as root of 1 minus sine 2x upon 1 plus sine 2x, and you have to prove that dy dx plus sec square pi by 4 minus x is equal to 0. Okay, so what will be the approach of doing this question? We need to prove this thing, that means we require dy dx, that means we need to differentiate. But before differentiating, I told you please simplify your question in the easy way. So how can we simplify? See, I'm not writing the question again. 1 minus sine 2x and 1 plus sine 2x. We know the identity that sine 2x is 2 sine x cos x. Okay, so this can be written as 1 minus 2 sine x cos x upon 1 plus 2 sin x cos x. But after this, I don't have any option to do. So what I thought, that in place of 1, can I just not write cos square theta plus sin square theta? So I am writing, in place of this 1, I am writing cos square x plus sin square x plus minus 2 sin x cos x. And in the denominator also, in place of this 1, we are writing cos square x plus sin square x plus 2 sin x cos x. Now don't you have a question that why cos square x plus sin square x? Can't we write sin square x plus cos square x? I'll give you the reason there. After just 2 or 3 steps, I'll give you the reason why we have not. So come here. Isn't this identity of a square plus b square minus 2ab, which is what? Cos x minus sin x whole upon cos x plus sin x the whole square, because this is also cos x minus sin x the whole square identity, and in the denominator you have cos x plus sin x the whole square. So commonly this square, so that this square will be cancelled with the root and will be left with cos x minus sin x upon cos x plus sin x. Okay. Now after this, in 11th class or in the inverse trigonometric functions, we have seen such type of questions. This is, you can mold it into the identity of tan a plus b or a minus b, whatever the situation is over here. So what we do, you take cos x common. So if you take cos x common, so here 1 minus, in this sign it will be sin x upon cos x. Okay. If you want to understand this, multiply cos x inside. So cos x and cos x into sin x, cos with the cos cancel, you will get the sin x. Okay. In this also you take cos x common. So 1 plus sin x upon cos x. This cos x and this cos x is cancelled. You are left with y is equal to 1 minus tan x upon 1 plus tan x. Sin x upon cos x is tan x. Okay. Now this is an identity. Actually we have to mold it into the identity, then only we can say. So see how. Can we write this 1 as tan pi by 4 because tan 45 is 1? This tan x as it is. Don't just do anything with this 1, okay? Keep it 1 only. Plus tan x. Can I write tan x as tan pi by 4 into tan x? Because tan 45 is 1 and 1 into tan x is tan x only. So this is an identity, actually, an identity of tan a minus b, because tan a minus b is tan a minus tan b upon 1 plus tan a tan b. I hope this is clear to you. Now you can differentiate, because it is very easy to differentiate now. So you differentiate, so it will be dy dx is equal to, what is the differentiation of tan x? Sec square. So sec square pi by 4 minus x into, if you go inside the angle, so pi by 4 differentiation is 0 and x differentiation is 1. Okay, so 0 minus 1 is minus of 1. So it will be minus sec square pi by 4 minus x. If you take here, so it will become positive. So dy dx plus this is equal to 0, and hence proved. I hope this question is clear to you. Okay. Now in the next lecture, we will come up with the inverse trigonometry, the derivative of inverse trigonometric function, which is very, very important topic for you. Okay. So stay tuned, do the question, ask the doubt, see the examples, do the practice. Okay. So till that, thank you so much. Have a nice day. Bye bye. Take care.